Well, hi, and thanks for joining me. My shop here today is August 4th, and day 2 with this tube tester. Yesterday I spent a long time discovering that this big meter doesn't appear to work at all. It appears to be burned out or in some way made defective. In the evening, as I was thinking about this, I realized that that could be the only thing wrong with this, is this meter doesn't work. Everything else could be working perfectly fine. And why don't I just hook up another meter to the spot, to the wires that drive this meter? And yes, it doesn't have the scale on it, but I think we can investigate this a little bit further and maybe find out that this unit actually works except for the meter. That might make it somehow valuable. I'm not sure. It's a very interesting device here, because it gives calibrated control over the voltages being applied to the tube. It's really easy, just plate, screen, grid, boom, boom, boom. That's kind of neat. And some other measurement elements here. This is an interesting tube tester in that sense. So what about the meter here? Now, the meter may have its what would you call it? Its ratings written right on it. Let me just spin this away here. Often the meters will tell you how good they are. They often have it written right in the corner. And I'm looking, and there's nothing written on this. So I'm looking for, let me find, look at this meter. See this one right down in here? Full scale 200 microamps. So they're telling you about the movement right on the meter. I'm looking at the other meters here. It says set to 117 volts AC before reading watts, but that's not going to help it. But anyway, it is common for meters to put their ratings on it. Look at this one here. It's got ratings written here. Input impedance, and over here is I don't even know what that is. Some other chart of information. 0 dB and 1 milliwatt across 600 ohms. They just give you information about that's related to the actual, in many cases, related to the actual meter movement itself, but not this one. So, what kind of power does it take to drive a meter like this? Well, it would be similar to this one. This one tells you right here, 200 microamps, full scale. It could be something like that. So, so the real question would be what voltage is being put on here, and the only way to find that out is to measure it, and at the same time I'd be hooking up another meter. Sounds like a good idea to me. Sounds like a really good idea. Okay, I gotta find myself a nice meter I can somehow associate with this device. Here, let's find one. So kind of intent on using a vacuum tube voltmeter like this because of the high input impedance, but then I thought about, ooh, this is a hydro grounded connection here. I'm going to put that on one. I don't know what it'll do to the meter. I don't know where the meter is in the circuit inside here. This could be a bad move. So rather than use this vacuum tube voltmeter, we will use this one here. So this is just like a vacuum tube voltmeter, except it uses transistors to do its thing. So consequently, there's no connection to ground or earth. I can use this meter quite safely. So I'm going to hook this up to the wires that power this meter, and then we're going to, I don't know what I'm going to do. I don't know. I'll figure it out. One of the things I try to remember to do is always read the the label on the vacuum tube before I do something with it, just in case. So this is a 50C5, same as these other 50C5s that I have. And they are here. Actually, no, it's not the same. This is a 35C5. I have to look very closely at it. I put that one aside. I don't want that in the mix. So here's a 50C5. He says. 50C5. I can see the writing on it. So I'm going to plug this in, only because I think there's a better chance of having something happen on the meter here than if I don't have a tube in here. The tube tester is set up for this tube based on the information I found yesterday, based on this chart. Okay, so if I switch this on, what would I expect this meter to do right away? It would depend upon the scale setting. The lowest scale setting here is 0.3 volts. But I don't know. Hey, stop thinking. Let's try something. Stop thinking. Thinking is overrated. Okay, we're plugged in. The switch is off right now. There we go. So I'm going to put this to 100 volts just to have it. I'm going to go even lower. 30 volts. We'll put it there. The voltage used to drive this meter would be very, very tiny, I would think. So we may not see the meter move at all. I've got a switch here which will change the direction of the pointer, plus and minus. So there's a meter switch up here. Right now it's set on a dot between scales, as if that's a off or neutral place. It has one scale here called D/R, which I don't know what it is, and it goes up to 180. 180. These voltages go way up above 180. What is D/R? So this is actually a current reading, but that just means the meter's been calibrated. We to read current, we don't know what is really going to the meter. So let's put it on the current, because I do have a tube in. We'll put it on. I guess we'll leave it on the. Let's leave it on the high scale. 100. Stop thinking. Just do it. You're thinking too much. Yeah, we'll just flip it on. Okay, eyes on the meter here. That's not very exciting. How come the light didn't come on? Why didn't the light come on? Jim, what did you do to it already? Oh, I know what it is. I can't have this tipped up like this and have the power go. The power plugged in. I have to set this down or somehow access this. Oh, that's a toughie. Okay, that's a logistics challenge here. As it turns out, they've designed this so you can have it in this position and still manage to put the plug in, which I won't show you why, because I have to swing the whole thing around. But so I have the plug in. I'm going to put the power on. The switch is off. Okay, meter, are you ready? I'm going to switch it on. The tube should start heating. This is set. We're going to set this in the test position here, and the meter is set for current flow through the tube, plate current. I wouldn't expect this to go up until the tube warms up and starts operating, assuming any of this works at all. Okay, there's no tubes in here to warm up, so I flip the switch on. This is the only one. This is the only thing to warm up. Okay, here we go. And that was quick. I forgot about that. Well, okay. Yeah. What's quite a reminder I got there. I think it has to do with the setting of this switch. I'm going to set this way over to the set setting, which brings this control on. Goodness knows what's going to happen here. Here we go. Okay, now, is this meter showing anything at this point? And I believe with the way it's set, there's no attempt to heat this tube. Don't see anything here. Let's make it more sensitive. Oh, there is something there. Okay, so we'll fool around with the set switch. And what's this do? Makes the light flick. Doesn't do anything to the meter. Okay, so this is the meter switch setting. What if we move this around? It's doing nothing to the meter. Is this a real meter reading, or is this a zero thing? What's going on here? No, it's a real reading. So conceivably, this meter would be up also, like this one is, up here somewhere. I have this on set. You know what? There's an electrode selector also. Which doesn't seem to do anything. Okay, we're going to change the meter settings here. Nothing happening. Nothing whatsoever happening. Okay, we just switched to a completely different setting. Nothing happening, but maybe it's because this is on set. Okay, put this into the what looks like a neutral position for the switch. The meter switch selector. I'll switch this to H conductivity. H. So this is probably measuring the resistance of the heater in the tube. I don't really know. Here we go. Okay, nothing happened. Nothing bad happened. Nothing good happened either. Nothing is happening at all. That's the heater volts. We don't want to fool with that. The tube is not heating yet. So now we can do these insulation tests along here. We'll see what the meter does. That's AR. So this would be like anode resistance, screen resistance. Oh, did you see that? Did anybody see what just happened? Snap this a little further. See, the dim bulb light came on and the meter dropped to nothing. The next one is CH, which is cathode heater. I must have gone a little further yet. Cathode heater, it's nothing. Yeah, actually, it is moving this. It looks like it's just bouncing a bit. Let me try electrode selection change. Doing nothing to the meter. The meter's set on a neutral spot here. Or what I imagine to be a neutral spot. Let me show you what I'm talking about. See, there's a scale going this way and a scale going this way, and in it is a little dot that I have this control set to. It doesn't say off, it doesn't say anything. Right, put this here. Sorry about that. What would you want to try next? I'm going to change the scale here and see if the reading doesn't match. So right now we're on the 3 volt scale, and the reading I'm getting is about exactly half a volt. So if I go to the 1 volt scale, yeah, I get exactly half a volt. I'm kind of investigating the internal resistances that are feeding to the battery. Hey, look, this tube is heated right up now. When did that happen? When did that happen exactly? When I move this on to CH? No, it's still heated. These are the different insulation, or, oh, it's gone off. And I'm on the screen resistance. Now the next one is CHR. And it's heating up again. CHR would be CH. Cathode heater resistance. CR? CH, cathode heater. I don't know. And the next one is CH instead of, it's just C/H instead of CH/R. Cathode heater. I don't know. I do have the whole manual, you know. I actually have the manual for a different unit, right? It's not exactly this unit. But if we go to test, we're blowing the machine up when we put it to test. Blowing the machine up. I mean, there aren't that many settings here to change. You know, this says C/H and this has a C/H. Maybe they should be the same place at the same time. Maybe. Is the buzzer a warning? Well, I guess it is. Is it an intentional warning? Would they design a machine where you could easily set the controls such that you needed that kind of screaming warning coming out of it? Well, like, would the instructions contain stuff like never set this, that together because you'll blow the machine up? I can't imagine they would design it like that. So, you know, the other alternative is it's indicating something is wrong with the machine. It's not it's something bigger is wrong with the machine. Well, this hasn't worked out the way I was hoping. I was certainly hoping. What about these buttons here? Read the GM, calibrate the GM, set the GM. I guess when the calibration button's pushed. Well, you know, we're not in the test position here because the machine doesn't like it. But in this position, insulation test, it doesn't make any sense at all to do this, but let's do it anyway because... Hello. Anybody home? Postman always rings 32 times there. So that didn't do a thing. But there's another button. Read the GM. GM's poor. We got something. It kind of worked. It sort of worked. GM range. And we've got the meter to move. And I'm at the point now we're just flipping switches. I still have this on a setting that's like nothing. So why would you set this to, for instance, IA? That would be anode current. It doesn't give a scale. It would probably be so getting back to what I was just about to say, why would you set this to anode current and then perform these tests? These buttons override the settings up here because this is supposed to be in the set test position and the machine goes crazy. Does it go crazy with the tube? Nah, I gotta touch that tube. Yikes. I'll burn my hand for sure. Okay, we're gonna pull this tube out. What happens now if you go to set to test? Making no difference. I'm running out of things to try here. I don't know what else to try really. Even if this meter began to respond in some sensible way, my external meter, it would still have a heck of a time trying to calibrate this against this scale here. It would be very, very difficult. So other than finding out stuff, and I didn't find out very much, this is probably leading nowhere, really. What a shame that this is, you know, the case is also cracked here. I wonder why that is. Just a stress crack. It's not right in the corner. Oh boy. And am I absolutely convinced this meter is not working? Pretty convincing yesterday. But I suppose being here now, I should give it another check. Just to be absolutely sure. Now we got this, you know what? This meter's up right now. Reconnect this meter, it should be up too. This is just a false thing here. It's because it's hanging upside down. This is a gravity measurement here. So if this voltage were to touch the meter here, if I were to reconnect it, this pointer should go a little further. Okay, reconnecting is just another clip lead. There's only one wire is disconnected. Gotta reach around the back here. Let me turn it off while I do this. I will connect it. It's going to take me a minute to make a connection there. Okay, I think we're ready for another try. So this meter is now connected in the way it normally is, and this one is still in parallel across it. And we will see what happens here. I don't expect this meter to move at all, of course. So we have this set in a position. I believe it's going to cause this meter to go up a bit. Here we go. Okay, did this guy move? I didn't even. I was watching this one. There's just nothing happening here whatsoever. So, you know, that raises the question of, well, can you fix a meter like this? And my first answer is no, you cannot do that. So the pointer's moving here as I adjust the. This adjusts the end of the coil spring, causing the pointer to, you know, adjust the zero on the pointer. So, if we wanted to try to fix this, it just. I don't think it's possible myself. Did I have? Yeah, I'm going to have to sit here and think for a while. I'm going to stop for a bit and ponder that attempt. Should we attempt that? Gee, I just don't know. Well, after thinking it through a little bit, I think the best thing I can do at this point is abandon ship, really. Trying to fix this, it's a really long shot. I've never really tried to fix one of these. In here is a very delicate coil. Well, I'm going to stick my clunky soldering iron in there. I don't know what to think. It's pretty easy to get this meter out. Assumably this cover pops off, and then you can see or access right into here. Taking it further apart, there's a cover on the back. At what point do you get access to this coil that you can see the connections or in any way? I don't know. You know what? I think it's a journey not worth taking. Ultimately, this is just another tube tester of a weird sort. I have many of them myself. This one doesn't belong to me, in fact. It's kind of on loan here. I think I'm going to, you know, and then I run the risk of doing more injury to this machine if I continue playing around with it, especially with that weird relay chattering thing that's going on. I think the best thing I can do is pack this guy in and move on to another project where success is more likely than here. That's really too bad. because if it wasn't for this meter, I think this thing would be working. I think. We can't know for sure, and it would have an interesting. It's interesting, again, because of the independent controls you have over plate, screen, and I got to think a little more about this. But I think I'm done for today. I have so many other things I need to be doing today too, aside from being in here. So I think I'm calling it quits for today anyway. But I'm pretty sure I'm calling it quits on this whole project here. Oh well, they don't all work out. They can't all work out, can they? Can they all work out? I don't think so. Thanks a lot for watching, and see what's in here tomorrow. Who knows?